Okay, we're back with a little update here. Started pulling this distributor apart, finding a lot more problems here. Like I said, the one wire that we knew was bad was this one here, which went to the igniter, which that end, the spade connector and everything on that end looked bad. The wire insulation is all burnt back and everything, so we know that wire there has been compromised. But once we get farther back towards the connector, we got good soft wire. The insulation's good back here, so we're probably pretty sure to bet we can just splice in back here and not have to worry about the connector. But as we get into it, we find out that this connector here, the boot on that is actually burned. You can tell there's a lot of high resistance in this wire here, and it's heating up, and it's actually burning at the connector. So we know we got a bad connection in that connector right there, because it is causing a lot of high resistance and is burning that boot, which you can see on the other wires here. You know, it's got a little shrink wrap tubing or whatever around the connectors, and those all look good. So those are either low impedance, or you know, the connections are still good on those because they're not overheating. We found a lot of corrosion on the coil contacts. You know, and that's a good thing for high resistance. You know, if you get a little bit of corrosion built up, especially on your high voltage wires here, side of your wire, shrink wrap tubing or whatever around the connectors, and those all look good. Reference, it's not good. Those are either low impedance, or you know, the connections are still good on those because they're not overheating. I found a lot of corrosion on the coil contacts. You know, and that's a good thing for high resistance. You know, if you get a little bit of corrosion build up, especially on your high voltage side of your wiring, that's going to create a lot of heat. You know, on your 5-volt reference, it's not going to overheat, but it doesn't take much of a bad connection to compromise your connections, because you only got 5 volts to work with. So even just a little bit of resistance in that wire is going to affect your voltage across that connection. So, but if you see down in there, that's actually your cam timing, or your cam sensor down the bottom. That's your reluctor in the bottom there, and that's for your cam sensor. And this is right here, this is your trigger. Basically that takes the place of the points on the older cars and stuff, to where they used to have a point system. This is your pickup coil, and that little cam right there, that tells you where number 1's firing, or it gives the computer a reference to where number 1 is. So when that thing spins around, the cam sensor down in here actually fires your injectors and fires your coils and everything like that. But this one right here, that's actually the timing segment of that tells you when that breaks that signal. That tells the computer that's where number 1 is. So the more I go through this and find that we got some overheated connectors and all that stuff, you know, we're gonna have to probably build some jumpers or whatever, rebuild this harness in here and get rid of those high resistance connections in there, and do a lot of cleaning and everything like that and stuff to make sure that the ones that are still good are not losing any voltage or anything in that. So we're going to have to cut this wiring harness back and resplice in and solder it and heat shrink it, and we're going to have to get these wires back to the point to where they're trustworthy again. So we're going to go through this distributor, and we're going to pick out all the bad wiring, all the bad connections, all the, you know, trouble points or whatever in this distributor, and make sure that everything is good. Make sure the wiring is still soft and it's not hard and brittle, or don't see any indication of heat build up. I've actually seen the insulation to where you actually can't see the wire, but on the insulation it's all bubbled up or whatever, it turns black, and you know that there's probably a broken wire or something inside that insulation that's causing heat build up in that wire, and the insulation will literally bubble up and turn black or crack or whatever that way. So without even cutting the insulation off, you can actually tell there's a bad connection or something going on that wire, and something needs to be looked into. So that's what we're going to do now, is we're going to go through all this wiring We're going to cut the shrink tubing back. We're going to check all our wires, make sure there's no insulation problems, make sure the wires are soft, make sure that there's no burn through on the wires, and we're going to go ahead and replace anything that is bad.